Welcome everyone in the next session of public transport concept. You can follow this session for the complete set of the lecture related to urban and suburban regional transportation concept, strategy and organization. This is our fourth session. In this session, the main theme of this lecture is about that how we can provide the service according to the customer, passenger, or individual demand. So to fulfill that specific demand is the core purpose to understand the concept of the public transportation. As you can see here in our previous session, we have already covered the part of a regular buses, BRT, tram, streetcar, and automated guided transit. So which we consider them as a street transit mode as well as of the medium performance transit mode. Today, we will mainly focus on the high performance transit mode, and we will also try to understand that how we can tackle that how we can fulfill the passenger demand. So keep in mind all those the conceptual framework and understanding is for the purpose to fulfill the people demand. So as a transportation system engineer, your planning, your strategy, your concept should be at the same level to fulfill the people demand. For example, without survey, without conducting collection of the data and to understand the kind of a framework for like which you need to design as a transportation engineer to provide the public transportation system to any city, you cannot be a successful planner. So to understand those conceptual framework is very much important as a transportation system engineer. Today, we will mainly talk about the high performance transit mode, which actually put us or which tell us about the rail rapid transit. So RRT, or we call that metro as well, or we also call it MRT, mass rapid transit as well. It's actually denoted with so many uh, uh, words such as like heavy rail or like metro, or we also call it high capacity public transportation, which is generally found in the urban area and which only function in the within the CBD area, the central business districts. This type of a transit system that primarily or traditionally runs below the surface, which we also call the tube system or underground system, or we also call it subway system as well. This is a one very typical example, as you can see here, that the subway or the underground is the mass rapid system is actually operating in the underground tube, and from that very picture you can have a look. It have a very large station along with multiple doors. So you can imagine if the same station, if the same type of a mass rapid transit operate in any city which have a very huge lighting and boarding capacity in any mega city. Okay, so you can imagine that this is the most suitable and economical solution to provide that type of a service if you have a very huge demand. Today, we will also try to understand its operating capacity, its performance, its reliability, and as well as its speed. In the most important uh, the indicator that why we prefer such type of a services, because the initial cost is no doubt is quite higher, but the operating capacity per passenger in the longer run is very short, is very much economical. This is another example so that you just have a look at what type of a perfect low floor system, low floor mass rapid transit, very large infrastructure we are talking about. So those picture are actually for the purpose to give you a brief idea to put the same picture in your mind before to go in a every or very minute details. As you can see here, if we call it um, rail rapid transit or metro or MRT. So the first thing is it only function on the right of way category. A is, you can see here in the very first point, is you can see here it only work at the grade. So grade means where we have the issue of a terrain, or we want to go from the lower end to the higher end. Okay, so this is a very special condition. So that could be there is a possibility, for example, if you want to connect any city which have the lower grade in the upper grade. But in the rail rapid transit, we actually do not change our plan if even if we need to construct something on the grade as well. Okay, which is of course not then 4 or 5%. Okay, and the second is we also can construct it on the uh, embankments as well. Okay, so this is the construction of the which allow railway line to pass at the acceptable level, and the gradient may be uh, over the low lying ground area. So if there is a kind of a soil cutting or excavation is required to allow the railway line to pass it in a kind of acceptable level, so we also do not go back as well. So we also come up with that type of a solution as well. If we need to pass the railway line at the viaduct. So viaduct is a type of a long bridges or series of bridges which usually supported by a series of, could be arches, could be span, which actually connect a very large area over the valley or over the water or maybe over the road as well. Or maybe we need to construct tunnel or maybe do some type of a digging as well. So in the rail rapid transit, all of those infrastructure could be possible. This is the reason that it is considered one of the most expensive infrastructure cost, at which require huge infrastructure cost at the construction level. And so the question is why we select such type of a infrastructure. As you can see here, we have covered the street transit, we have covered the medium transit mode. So according to the high performance transit mode, it have a capacity up to 70,000 spaces per hours, which is still operating in the New York as well as in the Hong Kong. So you can imagine that uh, according to its capacity, even we can increase the same capacity as well up to maybe 90,000 or maybe 100,000 people as well, or spaces per hours. It have a very high performance transit mode. High performance means in terms of a speed, it can reach up to 80 kilometer, which operating cost or the kind of the starting speed is from 30, and which can go till the 80 kilometer per hour. Okay, and it have the low operating cost per space per kilometer. The question is how we can conclude or how we can determine the low operating cost. Low operating cost per space per kilometer means the capacity of a single train of the people sitting as well as the standing means open capacity. So for example, if this single train have the 400 seats and it have the capacity of a 600 spaces within the same metro, so we have the total capacity of a 1000. So always we will the total cost would be 1000 divided by the total cost, so we can determine the cost per space per kilometer. And its frequency can also go up to 40 trains per hour. So if we have any mega accident or many not accident, even mega activity is going on in any city, such as football, cricket matches, or like rugby matches, so we can increase its frequency as well, as I already mentioned, which is needed high investment cost and quite extensive and mega construction cost. It could also work. It's still functioning. Its best example is Lyon, New York, Germany, France, where we have almost the third rail or the overhead conducted system, or we have the electric propulsion system as well. Okay, and it's usually function at the automatic or mainly driven with a very fail-safe signal system as well. So at the same time, it is operating by the automatic as well as of the driver as well for the maximum safety in operation. So the maximum station capacity is quite high, which is almost up to 750 meters. So you can imagine, so we can hold, I mean, like a lot of people can the each and every station have a very huge capacity in terms of the handling of the passenger. The second part of the same is RRT, which we call Regional Rapid Transit. It is also the electric traction lines, which actually connect the urban city with the suburban city, which have a bit higher speed as compared to the tubes system, which actually operate tube as well as on the ground as well. So it have a bit long lines which connect, which have huge capacity as compared to underground, and it usually penetrate within the city center through the underground tunnels. And its best example is Subbahn station, Schnellbahn in Munich, Germany, and PR in Paris. This is a typical example from the Germany, from the Deutsche Bahn. Is you can see here, it's this one is called Schnellbahn, S-Bahn, which actually connect the urban and suburban areas. This is the also the example from the France, which connect urban with the suburban areas. Is you can see here, it's a very long and lengthy train line which have a capacity of a almost more than 1000 people. Okay, so keep in mind whenever we will talk about high performance, low performance, or street transit, we will mainly talk about two type of a characteristic. The first one is the physical characteristic, while the second one is the operational characteristic. So those two will be our set of indicators through which we usually compare those two parameters. Those two, for example, if we want to evaluate, so we will do that part in those two parameters. The first one is about physical characteristic, which have the high capacity transit mode, which usually operated on the almost regional or the right of way category A. And the stations have also the overhead shelters, which is covered, so which provide you the very safe area in the during the monsoon or like rainy season or the snow season. It have also the information is already there displayed regarding the headway, regarding the fare, regarding the whole city map, that how you can go from origin to destination. And the mass rapid transit is actually functioning on the intelligent transportation system, which is connected for the passenger information, through which you can see that which train is moving at which place and which train you can connect from origin to your destination. Okay. And then the second parameter is about operational characteristic. Operational characteristic means the first one was that you need to build it at the station or within the transit lines. So this one is that how the same type of a rapid transit is actually operating. Is it provide you the maximum comfort, safety, operation, speed, reliability, and so on. And the one which we can find that what type of a headway we have. Of course, the rapid system have the short headway. Means headway means the coming of the second train after the first one. So the total distance between the tail of the first train in the head of the second one, which is about to come at this station. This is called headway, and the space between two stations is from 0.5 kilometer, means 500 meter, to 2 kilometer, and it have the simple route structure which almost connect each and every part of the city. And we have the off-board fare collection, means when you enter at any system, so you need to take the fare at the same time, so you don't need to buy something from like very advanced, and we have multiple options. You can even buy the same ticket from your online app. You can even buy it from the at the same station as well. Because the station length is from 750 meter to 1 kilometer, so it have the high capacity and high holding capacity in terms of the passenger exchange from one line to another line. So now we are trying to eliminate, or I would like to give you the brief idea that what are the physical and operational characteristics of all the transit mode which we have covered so far. For example, if you talk about the non-articulated buses, non-articulated, which I already mentioned, if there is a kind of a mechanism which allow the bending if the any curve, or which have a bit more flexibility to turn or take a short type of a turn at the curve, that is called articulated, means maneuvering capability. Okay, moving capability within short curve. This is called the non-articulated buses. So those buses have the single lane and single stopping locations, which have the typical headway from 60 seconds to 40 seconds, and its capacity in the per hour, we have almost 5,500 capacity, in which usually provide more seating arrangement, and we consider them as a comfort level of service. Next one is about the articulated buses, which have the very straight buses, which does not provide the same type of a service. So the only one difference between non-articulated and articulated, that if we have the short type of a curve, so then we will use the non-articulated buses. But for the articulated buses, we need to construct the long and straight curve. The alignment should be straight, which is in some situation, for example, if we have water, if we have junctions, if we have crossing, if we have any other type of a road transportation is moving on, or like railway line junction. So in such situation, we sometimes need to construct the overhead bridges or tunnel as well, because the same bus does not have the capacity to maneuver and does not have any mechanism to bend at the curve. Okay, so those buses have the very straight alignment or like shape. Almost it is same as like the non-trolley buses, but of course we have a bit more kind of a spaces as compared to non-trolley buses. Okay. If you talk about the high capacity buses, which we means BRT, bus rapid transit, which is currently operating in Karachi, in Lahore, in Peshawar, in Islamabad, in the country like Pakistan, but in most of the countries of the developed countries. So this is also considered the street transit mode, which actually operate it every in the every city. Those have the high capacity as compared to articulated and non-articulated buses. Okay, they have theoretically more spaces, and the speed regulation control is also more strict and more kind of coordinated as compared to the other regular buses. Then we have which we call the streetcar or the trams, so which have also kind of a bit more long stations. The capacity is also a bit higher, and the speed can also go a bit more as compared to the BRT and other kind of articulated buses. And of course, it mainly function on the right of way category B and C. And then in the very last, we have the light rail transit, which we call LRT, which have more spaces, but its function is mainly depending on the operation type, frequency, and kind of comfort level. Of course, the one which we just finished about mass rapid transit, or which we called rail rapid transit, or like metro system, which have almost capacity up to 70 to 80,000 spaces per hour, and which typical headway is, of course, less than 1.5 minute, and it have a bit more advanced signaling and control system, and more efficient in terms of the safety, comfort, and reliability as compared to LRT buses and BRT. And then we have the regional rail system, which usually connect, as I already mentioned, between the urban and suburban area. So those are the most diversified in terms of its shape, in terms of its operation, in terms of its physical characteristic as compared to other transit modes. It have more capacity. It also could function, it usually function on electrical as well as diesel, and some part it is also connected at the third rail system as well, which we call the electric system as well. It may not have higher capacity than the mass rapid system until and unless if it does not have the kind of a advanced and technical and operational technology, because that specific system we usually use to connect the urban and regional, so where we have more land, and the we don't have any issue of the safety as well, because it's usually operated in the open environment, and it have the quite a bit more long headway as well. Thank you very much. If you have any question, you can